Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P0141 indicates a problem with the heater circuit of the secondary heated oxygen sensor, HO2S, which is often referred to as sensor 2. In the context of emission control systems, the secondary HO2S is tasked with monitoring the efficiency of the catalytic converter and ensuring that it is functioning correctly by providing feedback to the engine control module, ECM. This sensor is typically located downstream of the catalytic converter. The heater circuit within this sensor helps ensure it can operate optimally, especially during cold start conditions, where the engine needs to heat up quickly to reduce emissions. A malfunction in this circuit can lead to incorrect fuel mixture adjustments, resulting in poor fuel economy and increased emissions. It is crucial to address this issue promptly to maintain your vehicle's performance and compliance with emission standards. The DTC P0141 specifically relates to the failure of the secondary HO2S sensor 2 heater circuit. This sensor plays an essential role in ensuring the vehicle's emission system operates efficiently. Positioned after the catalytic converter, its primary function is to evaluate how effectively the catalytic converter is transforming exhaust pollutants into less harmful emissions. To perform accurately, the HO2S must reach an optimal temperature quickly, which is facilitated by its internal heater circuit. If this circuit fails, the secondary sensor can't reach the necessary temperature, leading to erroneous readings that may cause the engine's computer to adjust fuel mixtures improperly, resulting in poor performance and increased emissions. Understanding the location and function of this sensor is critical to diagnosing the problem effectively. Several potential causes can trigger the DTC P0141 warning. The first possible cause is a shorted wire in the heater circuit, known as the IG1 ACG line. If this wire is damaged or shorted, current cannot flow effectively, impacting the sensor's operation. The second cause could be a complete failure of the secondary HO2S itself, where the internal components of the sensor no longer function correctly. Another potential issue arises from open sockets within the wiring, either in the IG1 ACG line or the SO2HT line. Open circuits prevent the necessary voltage from reaching the sensor, thereby impairing its function. Each of these causes requires a systematic inspection to identify and resolve the malfunction efficiently. When DTC P0141 is triggered, drivers may notice multiple symptoms that indicate a potential issue with the vehicle's exhaust system. The most immediate is the illumination of the check engine light on the dashboard, signaling that the on-board diagnostic system has detected an anomaly. Additionally, increased emissions are a significant concern, as the vehicle may fail emissions tests due to improper readings from the secondary sensor. Drivers may also experience poor fuel economy, as the engine control module, ECM, struggles to adjust fuel mixtures effectively based on inaccurate data from the HO2S. Understanding these symptoms is essential, not only for diagnosing the problem, but also for mitigating potential impacts on vehicle performance and environmental compliance. The first step in troubleshooting the DTC P0141 involves verifying the problem through a systematic process. Start by turning the ignition switch to the on, second position, without starting the engine. This action activates the vehicle's electronic systems. Next, use the Honda Diagnostic System, HDS, to clear the existing DTCs in the system. After clearing, start the engine and allow it to idle, watching the HDS for any pending or confirmed DTCs that reappear. If DTC P0141 is indicated, it confirms the ongoing issue related to the secondary HO2S heater circuit. Conversely, If it does not appear, it suggests that the problem may be intermittent. In this case, it is essential to inspect for loose connections or corroded terminals at the sensor and the engine control module, ECM, before proceeding. In the second step of troubleshooting, the focus shifts to diagnosing issues with the IG1 ACG line, crucial for the operation of the secondary HO2S heater circuit. Begin by ensuring the ignition is turned off by switching it to the lock 0 position. Locate and check fuse number B2, which is a 15-amp fuse housed in the under-dash fuse and relay box. If the fuse is intact, it indicates that the IG1 ACG wire is likely not shorted, allowing you to move forward with the diagnosis. However, if the fuse is blown, it is necessary to repair any short circuit that may exist in the IG1 ACG wire, leading from the secondary HO2S heater circuit to the fuse. Finally, replace the faulty fuse before proceeding with further investigations. Step 3 entails checking the internal heater resistance of the secondary HO2S to determine whether it is functioning properly. Disconnect the secondary HO2S sensor 2 4-pin connector to isolate the sensor from the system. Using a multimeter, measure the resistance across test points 1 and 2 on the connector side, specifically aiming to find a resistance value between 5.4 and 7.3 ohms at room temperature. This measurement is critical, as it indicates whether the heater circuit within the sensor is intact. If the resistance falls within this specified range, the sensor is likely operational, and you should proceed to the next step. On the other hand, if it falls outside this range, it necessitates replacing the secondary HO2S before continuing with other troubleshooting steps. The fourth step revolves around checking the internal circuit of the secondary HO2S sensor to ascertain its integrity. With the sensor side still disconnected, verify continuity by measuring between test points 1 and 2. The test conditions should have the ignition off, and the sensor should remain disconnected from the rest of the system. Continuity signifies that the electrical path between the sensor and ground is intact, allowing current to flow as intended. If continuity is present, it indicates that the secondary HO2S is functioning correctly and will necessitate replacing the sensor to resolve the DTC P0141 error. Should continuity not be found, you will then need to advance to the subsequent steps of diagnosing the wiring connections involved in the SO2HT line. In the fifth troubleshooting step, checking the failure area associated with the SO2HT line is essential. Begin by turning the ignition switch to the on 2 position to power up the system. With the secondary HO2S sensor 2 4-pin connector still disconnected, measure the voltage between test points 1 and 2, which are located at pin numbers 3 and 4 of the connector. This measurement will indicate whether the proper voltage is present to support the operation of the heater circuit. You should be looking for a reading that reflects battery voltage to confirm the wiring is intact. If battery voltage is noted at this stage, it will lead you to the next troubleshooting steps. Conversely, if no voltage is present, further investigation into the wiring and connections will be necessary before continuing. Step 6 requires a detailed examination of the SO2HT line by checking for continuity, which is necessary for correct sensor operation. Begin by ensuring the ignition is turned to lock 0 to deactivate the electrical systems. Then, jump the SCS, short circuit suppression, line using the Honda Diagnostic System, HDS, to facilitate your testing. Next, disconnect the ECM, engine control module, connector B, which is the 49-pin connector designed to interface with the engine control system. With this connector disconnected, check for continuity between pin number 4 of the ECM connector and body ground. If continuity is present, it indicates that the SO2HT wire is operational and leads to potential issues elsewhere. If continuity is lacking, repairs must be made for any short in the SO2HT wire before proceeding. The seventh troubleshooting step focuses on verifying the integrity of the IG1 ACG line by measuring the voltage across relevant test points. Turn the ignition switch back to the on position while keeping the secondary HO2S sensor 2 4-pin connector disconnected. You will measure voltage between pin number 3 of this connector and body ground. The objective is to confirm the presence of battery voltage at this connection, indicating that the IG1 ACG wire is not compromised. If battery voltage is confirmed, the wiring is sound, and you should proceed to the final steps of the diagnosis. If there is no voltage detected, repairs must be implemented in the IG1 ACG wire from the number B215A fused to the secondary HO2S to rectify this issue. In the eighth and final troubleshooting step, you will perform an open wire check on the SO2HT line. First, ensure the ignition is set to lock 0 to turn off all electrical connections. Then, connect your HDS to jump the SCS line again. Next, disconnect the ECM connector B49P, as this will help isolate the circuit you are testing. Check for continuity between pin 4 of the ECM connector and pin 4 of the secondary HO2S sensor 2 connector. If continuity is established, the SO2HT wire is intact. However, in the absence of continuity, repairs will be needed in the SO2HT wire between the ECM and the secondary HO2S. After repair, recheck to ensure that the continuity is restored before moving on to final verification. Once all troubleshooting and repairs have been completed, it is vital to verify that the issue has been resolved. Start by turning the ignition switch to the lock 0 position to ensure all systems are off. After this, carefully reconnect all the connectors that were disconnected during the troubleshooting process to re-establish communication with the car systems. Next, turn the ignition to the on-2 position and utilize the HDS to reset the engine control module, ECM. This reset is crucial to clear any diagnostic trouble codes in the system. Following these steps, you should perform the ECM idle learn procedure, which allows the ECM to relearn the correct idle settings. Finally, check the OBD status to determine if DTC P0141 has cleared or if it still persists, thereby confirming the effectiveness of your repair. To reduce the likelihood of experiencing DTC P0141 in the future, a proactive approach to preventive maintenance is essential. Regularly inspect all electrical connections related to the secondary HO2S to ensure that they are clean, tight, and free from corrosion. Corroded or loose connectors can lead to intermittent electrical issues that may trigger diagnostic trouble codes. It's also important to maintain the integrity of the wiring insulation throughout the vehicle, as frayed or damaged wires are more susceptible to shorts or opens that can cause system failures. Additionally, keep the vehicle's ECM updated with the latest software from Honda. This can enhance its ability to manage sensor data effectively, preventing faults due to outdated programming. Combining these practices can lead to improved vehicle performance and reduce diagnostic issues. In summary, the DTC P0141 code indicates a malfunction within the heater circuit of the secondary HO2S, a critical sensor for emission control in the Honda Civic models from 2011 to 2015. Understanding the components and connections involved, including the IG1 ACG and SO2HT lines, is essential for effective troubleshooting. Each step in the diagnostic process must be carried out meticulously to identify whether the issue lies within the wiring, the sensor itself, or the ECM. Utilizing the Honda Diagnostic System, HDS, smartly throughout the diagnosis can significantly aid in determining the root cause quickly. Remember to perform a thorough verification after repairs, along with preventive maintenance practices to avoid future issues. Addressing this DTC promptly can not only enhance vehicle performance, but also ensure compliance with emission standards. Please like and subscribe to the channel. See you next time!